want to refer to this again. Okay, so I hope you've got your graph still there. It's probably better than mine, actually. The exercise I just gave you had to do with velocity and speed, mainly. It addressed displacement as well, but it's motion, right? So it's about how things move, which is why they ask all these questions. Okay. So I want to pose a question to you, which is, for our Mandarin, right? What's the average velocity over the first 10 seconds? Okay. Now, just before we deal with that question, I just want you to be cautious. You might have noticed it as you start to answer these questions, right? But when they say the first 10 seconds, or the third second, or the fourth second, you've got to be very cautious. So here's, for example, what you're looking at for a number line just for time. Okay. So when time is equal to 0, that's sort of, we don't usually talk about positions in time. Okay. They're like the third hour you were doing this, or you know. So what does it mean when you say the first second? It's the entirety of t equals 0 to t equals 1. That's what we would call the first second. Okay? So if we said the fourth second, right? The fourth second begins 1, 2, 3, 4. The fourth second begins when t equals 3. That's a bit confusing. Say that there. This is the fourth second. This is the first second. Can I help you, Mrs. Reese?
Yeah, you almost read. 2006. Remember how you skipped
The answers, yeah.
It didn't go up.
Okay, I'll just double check
It hasn't worked for some
Yeah,
reason.
that's okay. Maybe just haven't linked it.
No, I said to them that you definitely did it. So.
Yeah, okay, thank you.
Thank you.
Okay, what are we up to? Fourth second is t equals 3 all the way up until t equals 4. Okay, I know I always, not always, I often made this error that you think the fourth second starts when t equals 4, because you're like 4, but actually it starts a bit earlier, okay? Alright, now therefore, what is the average velocity over the first 10 seconds? Can we work it out? This is where the object is at the 10th second, okay? So how would we go about working out average velocity? What do we need? What information do we need? Good, we need to know how far it's been displaced, okay? Because velocity is equal to displacement over time, okay? And we already know what the time is, it's 10. So, let's work it out just quickly so we have some actual numbers here, okay? When t is equal to 10, to get the displacement, I'm going to pop it back into my displacement equation, okay? So, here, when t is equal to 10, that's 10, 14 minus 10 is 4, so this is going to be 40, so that's going to be 120 on 49. Sorry, that's what x will be. Okay, you happy with that? Whatever decimal that ends up being, okay? So that's where I am. Okay, so therefore, what do I do with that? That's my displacement. I divide it by time, okay? So that gives you the average velocity being 12 on 49. Meters per deci, whatever, sorry, second.
Wait, but it says first 10 seconds in the question.
Sorry, say it again.
It says first 10 seconds in the question, right?
Yes.
Wouldn't that be
Oh, sorry. Yeah.
Yeah.
Time unit. Okay, right, thank you. Alright, so there you go, there's an average. Okay, now I just want to pause and have a think about what it is geometrically we've actually worked out. Displacement over time, okay? Displacement is our vertical axis, right? That's why I've got the x on it. And time's my horizontal axis. So what I've really done is I've worked out rise over run. Okay, haven't I? Over a certain interval, okay? So average velocity, this is the key idea, it requires 2 points, okay, in space-time. Saying that is just a fancy way of saying I know where it is and I know when it is, okay, space-time. It requires 2 points, so that's why when you take those 2 points and you join them up together in a line that's vaguely straight, what you get is this interval, and your actual velocity is equivalent to gradient, right? Okay, so when we talk about average velocity or average speed, It's like joining them up. Okay, it's getting a straight line. Okay, but here's where it starts to get fun, because you guys know far more than what? How old would you have to be to work this out? Like year 7, year 8, maybe? Quantum geometry is year 8, I suppose. You guys know much more than quantum geometry. You know calculus, right? So you can do much better than an average, okay? Gradient over 2 points, okay, that's sort of approximate, okay? But you can get it at any particular point in time, okay? You can get instantaneous velocity or speed. How do you get it? By our old friend, differentiation. Okay, so before, when we first introduced like calculus and stuff and differentiating in first principles, we said that you differentiate, you get the gradient function. Okay. Well, if you differentiate the displacement function, you'll get we don't call it gradient anymore. We call it velocity. Okay, so you differentiate displacement, and that'll give you a velocity function. Okay. So that comes with all this bundled sort of symbols and terminology. So let me try and explain what all of these are. I'm going to give